lot of people are fascinated by the idea that we are not alone. In fact, we have created a lot of stories and made up universes of space travel and how life outside of our world and solar system would be. We also have our own interpretations on how these extraterrestrials, or aliens, look like, ranging from monster-looking creatures to others that exhibit a human form. To this day, however, there is still no clear evidence on the existence of extraterrestrials, let alone having been visited by one. What we have are various theories from the best scientific minds in the world, each having some truth into them. One such theory that has fascinated me for years now asks this simple question: what if life on Earth actually came from somewhere else? This theory is called Panspermia, which came from the Greek word pan, meaning all, and sperma for seed. It basically hypothesizes that life exists in the universe and is distributed somehow by meteors, asteroids, or any form of space debris carrying microorganisms. I wouldn't be surprised if this is the first time you are hearing about this, and it's probably not one of the more popular theories out there. So let's dive into the video and I'll share with you what the theory of panspermia is all about. The earliest known mention of this theory was actually from a Greek philosopher named Anaxagoras. There's a book published about the philosopher's insights on the origin of life, and I have linked it down below in the description in case you're interested. It wasn't until the 19th century, however, before the Swedish scientist Svante Arrhenius had a detailed hypothesis of panspermia in his book, Worlds in the Making, The Evolution of the Universe. Again, I have linked this down below in the description if you want to explore this book in detail. Now, when you hear about life on Earth coming from somewhere else, are you thinking about men riding on meteors or spaceships? If you are, then you're probably watching too much science fiction movies. Though we cannot say for sure that this didn't happen, panspermia actually focuses more on the distribution of life on a microscopic level. To be more specific, we are talking about organisms called extremophiles, which thrive in extreme environments, whether it be a high pressure, high temperature one, or even the opposite. Without the discovery of these organisms, the panspermia theory would have been outright rejected by the scientific world, as it would have been impossible for life to survive interplanetary or interstellar travel. There are a number of different proposed mechanisms of panspermia throughout the years, each with its own theory on how life can be transported from planet to planet. Let's discuss each one in detail. The first mechanism is called Radiopanspermia and was hypothesized by the scientist Svante Arrhenius, who we mentioned earlier. He believed that organisms smaller than 1.5 micrometers can actually be propagated in space by the radiation of the stars. This theory, however, was highly criticized by a number of scientists, as they pointed out that space radiation will instantly kill all life forms the moment they are subjected to them. Several orbital experiments were also conducted by different groups, and they concluded that even just a slight exposure to the space environment instantly killed microorganisms unless they were somehow shielded against solar ultraviolet rays, which happened to survive for as long as 6 years in space. These organisms need minimal protection, and if protected by a boulder-sized rock of at least 1 meter in diameter, then space travel would be possible. Unfortunately, this clearly goes against the radiopanspermia theory, which leads us to the second mechanism, and arguably a more probable one. This is called lithopanspermia. Lithopanspermia is basically the transfer of organisms and rocks from one planet to another. Though there is no concrete evidence yet for this, scientists have performed various control experiments as to how they think lithopanspermia can occur. They broke it down into 3 stages. The first is planetary ejection, followed by survival in transit, and then finally atmospheric reentry. The first phase of panspermia is planetary ejection, meaning living organisms must first be ejected from a planetary surface. This process alone seems to be highly improbable, as you have to go through extreme forces of acceleration, temperature, and pressure all happening at the same time. Scientists have approximated these conditions to be the following. Shock pressure from 5 to 55 gigapascals. Now, to put this into perspective, a rice cooker has a pressure of 0.0001 gigapascals. A tire dough, on the other hand, of a properly inflated car has a 0.0002 gigapascals. Now, on the extreme end, the detonation of the most powerful bomb known to man, the CL-20, is about 48 gigapascals. So as you can see on the higher end, the amount of pressure that these organisms could be subjected to is even more powerful than the most powerful bomb known to man. Acceleration of 3 miles per second, which is roughly 5 kilometers per second, and a temperature increase from 1 Kelvin to 1000 Kelvin. If you're not used to the Kelvin scale, this would be negative 370 degrees Celsius to about 726 degrees Celsius. These numbers and the real-world comparisons appear to be extremely severe. However, scientists have attempted to simulate these conditions in controlled environments and found out that certain organisms actually do survive. That's just the first part, however. If these organisms survive planetary ejection, they need to survive years of constant exposure to the hazardous environment of space. This one is much easier to simulate though, as again scientists have experimented subjecting certain organisms to controlled environments or even low Earth orbit exposure. Now, the final stage in lithopanspermia hypothesis is atmospheric reentry. These organisms will need to be subjected to almost similar hazardous conditions that they were exposed to during planetary ejection and somehow survive crashing into the ground at tremendous speed. Despite the absurdity of these conditions, research conducted at the European Planetary Science Congress in 2015 suggests that all these are survivable for certain organisms. The next step is to consider the odds of these happening. A recent research conducted in 2018 by Harvard astronomers presented a complicated and well thought of analytical model, estimating the total number of rocky and icy objects that could be captured by planetary systems within the Milky Way galaxy. I have linked the article in the description below if you are interested to read more in the paper and their mathematical equations. A year before this research, the first interstellar object passing through our solar system was recorded, and scientists called it Oumuamua, which is a Hawaiian word meaning scout. Estimated to have been traveling for over 600,000 years, originating from the Vega system. This is a breakthrough discovery for the scientific world since it confirms the links between galactic planetary systems and highly supports lithopanspermia as the main vehicle for the transport of life throughout the galaxy. Scientists have also discovered a rock in Western Australia that is dated to be 4.1 million years old. Our world is only 400 million years young, so this is also additional evidence that intergalactic space debris can actually reach our planet. Though lithopanspermia may be the most scientific explanation of life on Earth, two scientists, Francis Crick and Leslie Orgel, have explored the idea that life on Earth may not have been accidental, and is the result of intentionally seeding life to it by an extraterrestrial race. They call this directed panspermia. This hypothesis actually surfaced because there were a number of counter-arguments made against radiopanspermia and lithopanspermia. Scientists have conducted a number of experiments that makes a strong case that both hypotheses can actually happen, but the odds of it happening are very low. Now, directed panspermia relies on the principle that life can be transported either through radiation or being embedded between rocks, but eliminates the randomness of it happening. There is no concrete evidence to direct panspermia, however. As there is, then it's almost the same as proving the existence of extraterrestrial life. The different mechanisms of panspermia believe that our existence is proof enough that we are not alone in the universe, as it relies on the fact that life didn't start on Earth, but was somehow seeded from space. If panspermia is somehow proven to be true, then it will be a big scientific breakthrough that will change how we tackle the ultimate question: is there life out there? In fact, we will be asking you questions like, where exactly do we come from? How do we get here? Until then, let's all stay tuned to the upcoming updates in astrobiology as we get closer and closer to the truth. Thank you for watching this video. If you want to see more videos similar to this, make sure to subscribe to the channel so you will get notified whenever I release new videos in the future. Also give it a like as it really helps this small channel grow. Thank you very much and hope to see you again.